Good day all of you. My name is Najia and we will be learning more about reflection of light through an experiment today. Now quickly let us summarize what do you mean by reflection of light. When light falls on a surface, it bounces back from it. This bouncing back of the light rays is called reflection. Okay. When light falls on a surface like a plane mirror, the ray which is striking the mirror surface is called the incident ray. The ray which bounces back is called the reflected ray, and the normal is the imaginary line drawn perpendicular to the point of incidence. Okay, as you can see here. Now, always the reflection of light follows two laws. What are the two laws? First law states that the incident ray, the reflected ray, and the normal all lie on the same plane. The second law states that the angle of incidence is always equal to the angle of reflection. Okay, the angle of incidence is formed by the incident ray with the normal at the point of incidence, and the angle of reflection is formed by the reflected ray with the normal at the point of incidence. Okay, now we are trying to prove these two laws, basically the second law, through a small experiment which you also can do it at home very easily. So let us start. So here I have taken a transparent box in which I have attached a protector at the base of the box. Okay, now at the base of the box I have secured the protector using transparent tape. Now behind the protector this is the plane mirror strip. As you can see, I am going to place this plane mirror strip at the back of the protector using a small stand. Now we have placed the plane mirror strip behind the protector with the help of the stand. Okay, and here I have taken a sheet. In the center of the sheet I have drawn a red line, okay, which will indicate the normal. Now we will place the paper in such a way that the red line coincides with the 90-degree mark of the protector. Okay, this will be the normal of ours, right? This, as you can see in the diagram, this is the red line which is indicating the normal. Okay, so here the normal is actually the crossing the 90-degree mark on the protector, and the plane mirror is behind it. Now what we will do is we will pour some amount of water in the box, and in the water we will add 1 or 2 drops of Dettol or detergent so as to help in scattering of light rays, so that we can see how the angle of incidence is formed and how is angle of reflection formed, so that we can see the rays clearly. Okay, so now as you can see, I have poured a small amount of water in this so that the mirror is immersed in it, and so as the protector. In this water we have added 2-3 drops of liquid detergent or a small amount of Dettol so as to increase the number of molecules so that scattering of light rays can be shown. Now see, here is the laser torch I have taken. Now when I shine the laser torch, can you see this now? Can you see the two rays? The incident ray is the ray coming from the laser torch, and the reflected ray is bouncing back from the mirror, as you can see. And if we look at it carefully from the top we will be able to see that the incident ray with the normal is making an angle of 30 degree. Same as the angle made by the reflected ray with the normal, that is also equal to 30 degree. Okay, so now let us see. If I shine the torch on the mirror, you can see clearly the incident ray and the reflected ray, right? If we try to measure it using a protector, we will be able to see that the angle of incidence is 30 degrees as well as the angle of reflection. Both are equal to 30 degrees. If I increase the angle of incidence now, the angle of reflection also increases. See, yes, it becomes 40 degree each, right? So the red line is the normal, angle of incidence this side, and angle of reflection that side. This diagram you can easily see in this case. This diagram can be seen. See, once more we will be able to see the two rays clearly. The same diagram we will be able to see in this experimentally. This is a simple experiment which you also can demonstrate at home using simple things. Okay, I hope you've liked it. Thank you so much.